Now, look at the first 12 problems. They're in what's called log form, logarithms. We're going to be doing this for a couple of days, but they're not hard. Logarithms are just another form of exponential equations. And we've already been doing that for about a week now, a couple of weeks. Here's exponential form, and I want you to watch me write it, because what you're going to do is you're going to go from one form and write it in the other, and sometimes you'll start in exponential and then write it in log. But it's very easy if you follow me. Here's the first step. First of all, let me tell you how to read this. And you'll understand what it's saying here. You read this as log base b of a equals x. The b is called the base. That's why I used a b for the letter. Log base b of a equals x. Did you get one of these papers? Okay. Now to write it in exponential, how many remember what the number's called that the exponent is on?
Base.
The base. Very good. That's why I'm going to show you how to make a connection here for your memory. This is the base of a logarithm. It's also the base of the exponential function, or the exponential form. So here's how you rewrite it in exponent form. B, not that way. B to the x power equals a. Now there's nothing to lose you on here. This is just the way you rewrite it every time. There's nothing to understand. Just recognize where the letters went. And you do the same thing every time. This is the b is your base, and this is your exponent, and it always equals a, or that number. Just the same thing when you rewrite it. It's the same every time. So take number 1 and write it in exponent form for me. Write it in exponential form. Number 1. It's easy. See, number 1 is what? Log base 4 of, is it 256 equals 4. Now, while I'm talking to you about it too, before I write it, you remember how I have this pet peeve and got upset about where you write your exponents? They aren't exponents unless you write them in a certain place. Yep. And they aren't supposed to be as big as the base. Some of you would write an exponent as big as this number and write it right beside it. It's not an exponent when you do that. When you write logarithm form, this b here is a subscript. It's supposed to be written smaller and down, like a subscript. A is not the exponent on the b. It's not an exponent. It's a regular sized number. All of this is on one line, and b is a subscript. Are you following me? You can't decide to write it the way you want to write it. You must write it correctly, or it's wrong. So, what is the exponential form for this? 4 to the 4th equals 256. And isn't that a true statement, a true equality? If you took 4 to the 4th on your calculator, you would get 256. Now, these are two forms of the same thing. How many remember in Algebra 1 you had an equation of a line could be slope-intercept form? Remember that? And could it also be standard form? And they were written two different ways, but still the same line or the same equation. Are you following me? Do any of you remember point slope form? Okay. All of those are the same line, just written in two different or three different ways. So this is exactly the same thing written two ways. You're just not used to log. You've never seen it before. Logarithms. Now that was so easy. Should I have to do any more of 1 through 12? No. I know why. I'll tell you which one we need to look at. And what I'm going to do is do an example. I'm not going to do one of those. I'll do one similar so you can do it on your own. Everybody look at number 4, please. Notice there's no base. No. Good guess, though. No. Just listen. You're guessing. You don't know, so let me tell you. Does anybody know what our number system is based on? No. It's not based on 12. No. It's based on powers of 10. When you read the decimal places, isn't it tenths, hundredths, thousandths? Those are powers of 10. 10 to the first, 10 to the second is 100, 10 to the third is 1,000. Don't we have a tens place, a hundreds place, a thousands place? So it's based on the power of 10. Well, that's what your base is when it's not written. So put it on number 4, put in a little 10 for the base. And just remember that any time they don't write a base, it's understood to be base 10 because it's based on our current number system. Does that make sense? No? Yeah. So just remember that if there's not a base with the log, it's automatically 10.
So if number 4 says log 10, then equals 1, we just put...
Don't tell me the answer. I don't want us to answer that yet. I want everybody to do that on their own. Now, yes. I don't want you I don't want you writing the answers for these. I want people to do this on their own. You don't do anything different there. It's just the base written to the exponent equals the number. Don't change anything. You just write it in a different form. You're trying to make this too complicated. This is very simple. Question. I don't want the answer now. Yes, it does. They're all true. If you're not writing them correctly, they won't be. But if they're written correctly, they will be true. Yes.
Like number 6, how would you put in a -2 for the x? When you put it 1 over...
No. We're not changing anything. Y'all making this too hard. All right, just listen. Just let me do one. I'll do one similar. Let's say you have... let's say you have this. Now I'm going to change it to exponential. You don't rewrite or flip anything. We're not flipping anything. You're just rewriting it using what I just showed you up here. Wouldn't this be the base? 7 to the -2 equals 1 over 49. That's all you do. Now, isn't that true? Because what's this negative exponent have to do with this? Flip it, which would be 1 over 49. But we're not flipping anything. We're not doing anything like that. We're just writing it from one form to the other. The same thing every time. Are we clear? All right. Now, I don't need to do any more of those, and you know it would take you about 5 minutes to write those answers, wouldn't it? It's not going to take any time at all, so please don't be doing it while I'm teaching the next section. All right, let's look at the next part, 13 through 28. Now we're going in reverse. Now I want you to write it, it's in exponential, write the log form for 13. It's over here, it's in exponential. I want it written in log. Yeah, just write the log form. We're not figuring anything out, we're just rewriting it in log form. Pretty easy. So we're over here in log form. We have 9 to the second equals 81, which is a true thing, isn't it? So, who wants to tell me? And can you read it correctly, Stephen?
Log base 9 of 81 equals 2.
Very good. Log base 9 of 81 equals 2. Okay? Now are we all right with this one? So we don't need to do any more of those, do we? Give yourself 2 bonus points if you got that right. You did or you didn't? Oh. And on number 1 up there, if you got that right, give yourself 2 bonus points. Now, here's the part where you actually use it to do something with it. Look at number 30. I'm going to clear this. Number 30 that says evaluate each logarithm. So we have a log base 2 of 16. They're saying, what they're saying is, let's find the answer to that. I'm impressed. How'd you know that? I know, but you're getting it. How many knew it was 4? Excellent, because that just means I'm a good teacher. All right. But here's how you set it up. You got to show your work. I'm sorry, I know you got the answer easy, but here's how you actually work out the steps. Put it equal to x first. Make it an equation. Now, isn't this an equation in log form? All right, now I'm going to prove why your answer is correct. Write it in exponential. Yes. 2 to the x power has to equal 16. Now, I know you can figure that on your head because you just did it over here. But let's say you were doing that quiz I gave you a few days ago. Didn't we just solve exponential equations like this? What did I tell you you had to get the same before you could set the exponents equal? The bases. Well, this one has a 2, so we got to write this one as a 2 at some exponent, which is 4. Now do you see where the 4 comes from? Because x, yes, equals. Once the bases are equal, we can do this, can't we? Ta-da! How many feel like you got this? It's grasping, your brain has swallowed it and absorbed it. And assimilated it completely. You assimilated. All right. You got a question or you got it? All right. All right, wait a second. We're going to do some of those. On all of these, you're putting it equal to x. You're going to write it in exponential form and find x, like we did on your quiz. That's why we did that first before we did this. Now, I want you to look at some of them, though, have some, I'm going to do one like number 50. This is similar, but I want you to do that one, so I'm going to do a different one. You got it. Don't say it out loud because you told everybody. Who do you think? All right. Let's say we want to solve this one.
1 extra 0.
I'm not doing 50. I'm doing one like it.
Okay.
Now, first of all, what did I tell you to do? First step, set it equal to x. So you can write it in exponential form. Secondly, Michael, what's the base here since it's not there? 10. Now, you don't have to write it in here if you don't want to, but if you want to do that just so you know. Now, write it in exponential form would be what? 10 to the x. No, we're not doing that yet. We're just writing it in exponential form. 10 to the x equals 1 over 1,000, doesn't it? Now, you got 2 ways to approach this. What is 1,000 equal to 10 to what power? Nope. How many zeros are there? 10 to the third. So this is really the same as that. But we don't stop there because remember the bases have to be the same. No? What do we do with this to bring it up? Yeah. We're not doing 50. I made this up. I told you I'm making up one like 50. So wouldn't it be rewritten like this? Remember, you can, a negative exponent, you can flip them. Now we have the bases exactly alike. We can set the exponents equal. And our answer is this. So you're going to have some where you have negative exponents as an answer. Stephen, you saw that right away, didn't you? I love it. A lot of you are seeing it right away. So this means you're picking it up. You understand the concept. Now, I don't think there's any others that are different there. I'll do one like 29. I don't want to do any of these because some of them don't repeat enough for you to do this. Oh, we're not doing 29. Mark out the story problem. Yeah, but if you work on this today, you could get done in class. Oh, yeah, let's do one like 41. That's a good one. Let's do one like 41. Please don't make the noises. I'm trying to record here. All right, let's say you have this. We know the base is what here? 10. And then you do this, 10 to the x equals, but what is this as a fraction? Then you can do it. How do you write decimal places as a fraction? Oh, we don't know how to do that. This is what? Tenths, hundredths. So it's 1 over 1,000. And we just did this problem a while ago. Didn't we just do that problem? So it's going to be x equals -3, isn't it? But so you make your decimals fractions, then you'll know what to do with them. Does that make sense? All right, I don't need to do any more of these. This is enough for you to understand. All right, your assignment is 1 through 53, all of them. But like I said, the other class finished it in 20 minutes, some of them. Because you can just write the answers down. Here's the other thing. I don't want this, no answers on this paper. Use a separate piece of paper. That's what you get for trying to work ahead. And remember, these have, you're not listening. Shh. Listen. These have to be, you have to show the steps on these. I will not accept answers only. All the steps on the last problems where you have to solve them. Oh no. Just rewrite those.